All right, on tonight's edition of Homework Help, we're going to be going over Quirky Quadratics. I said I was going to do 2, 3, and 6 for some class periods, but I'm actually going to do 2, 3, and 7. The back, I want to see what you can do by yourselves. And then this one down here, you kind of need a calculator for. If you aren't able to do this one in class at home, you can put this in your calculator and look at the table when you get to class tomorrow morning. All right, so let's take a look at number 2. So remember, when we're trying to decide if something is linear, quadratic, or neither, we start off by trying to find, so if delta y1 is all equal, then it's linear. If delta y2 is all the same, it's quadratic. And if you have to go further than that, it's neither. All right. And again, we have a third type of function we're going to learn about, but we're not there yet, so we're only focusing, is it linear, is it quadratic, or is it something else? Okay. So let's look at this one. I'm going to look. So first of all, I always check this only works. Doing this only works if my x values are increasing by 1. And in this case, they are. So I'm going to look at my change in y. So 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. That's my delta y1. And since my delta y1 has the same value for every row, that makes this linear. Okay? Now let's look at this one. Let's start by doing delta y1. Negative 8 plus 7 is negative 1. 1 plus 1 is 0. 0 plus 1 is 0. Okay? Okay, so that's not the same. Let's try delta y2. 7 plus 6 is 1. 1 plus 0. Okay, this isn't it either. This has got to be neither because my delta y2 wasn't equal and my delta y1 wasn't equal. Okay. Now, if your delta y1 is equal, you don't have to go out any further. You don't do delta y2 if delta y1 is the same. Does that make sense? Okay. So again, that's why this one is neither. Now, if my delta y2 had been the same, so like if this had been 6 and 6, then it would have been quadratic. All right. So let's look down here at number 7. We had a problem like this on the circuit that we did in class, the hallway circuit, and y'all were like, well, there's nothing there, so what is it going to be? Okay. So remember, if it's got an arrow, or even if it has a dot, we can find the other side, okay? Because the axis of symmetry is going to help us build out the other side of the function. And the axis of symmetry, so remember the axis of symmetry is an x equals equation that goes to the vertex. They've all got x's. Vertex, axis of symmetry, x. Okay, so if you're looking for the axis of symmetry, you're going to look at the vertex and find the x. Okay? So let's look at this. First of all, what's the vertex? Well, I can see that right here is where it turned around. And that point is 3, negative 4. Okay, and remember, if it's a maximum, it looks like an umbrella. If it's a minimum, it looks like a bowl. Okay, so this looks like a bowl, so I have a minimum. All right, so the axis of symmetry is the x value from the vertex, so it's x equals 3. So if I draw a line going through here, there is my axis of symmetry at x equals 3. Okay? So there we go. What are the zeros of the function? Well, I see one 0, but I don't see the other. And I could try to continue this line, but I'm not positive. So what I know is that the axis of symmetry, every symmetrical pair is equidistant, meaning the same distance from the axis of symmetry. So if this 0 is 2 away, then the other one has to be 2 in the other direction. Okay? So see if I have a point here, I have a point 1 away here. So I can kind of continue it that way. See, I've got another here. So my zeros are negative 3, 0, and 3, 0. Okay. My y-intercept, it's not asking me for it, is 5, 0, 5. So I know that if this is 3 away from 5, then its symmetrical pair is right here. So again, see, I can kind of build out, okay, just pretend that looks like it's parabola E, okay? So I can build this out. So I have a symmetric point at, at 2, negative 3, and 4, negative 3. I have another one at 0, whoa, my zeros, that's wrong, oh my gosh. That's not negative, my bad. That's 1, 0, and 5, 0. My goodness, I don't even know what to say, you guys. I'm so sorry. So I have one at 1, 0, and 5, 0. I've also see this other one up here at 0, 5, and 6, 5. Okay, so I know exactly what I just did. Do you guys know what I did? What I did here was I drew this line at x equals 3, and then I started treating it like the y-axis. So be careful. Don't do what I just did. Okay? Now here they're asking us, we kind of already found this. What's the point symmetrical to 0, 5? 6, 5. Okay, so don't forget, if you're trying to fill out a table here, if you're trying to figure out, if they give you something like this where it stops right here, remember, you can use the axis of symmetry. See, if you have a point 2 to the left, you're going to have another point that matches it 2 to the right. If you have one 3 to the left, you're going to have one 3 to the right from the axis of symmetry, and you can build out the rest of your parabola that way. All right? If you have any more questions, make sure you jot them down so I can answer them for you tomorrow.